Good morning, everyone, and welcome to the Fiber Broadband Association's Fiber for Breakfast. We're now in our 11th episode of 2024. Before we kick off, I'd like to thank Wesco, the platinum sponsor of Fiber for Breakfast. In Washington, on Monday, President Biden released his 2025 budget, which included a request for $6 billion in supplemental appropriations to fund the Affordability Connectivity Program, ACP. This request was first submitted to Congress last October, but to date, additional funding has not been allocated by Congress. The last full month for the ACP program will be April, and which will impact over 23 million households. While there's been bipartisan efforts to find a pathway forward, the clock is ticking and a resolution has not yet been identified. The Fiber Broadband Association continues to urge Congress to fund ACP through the end of the year. The Fiber Broadband Association's next regional Fiber Connect workshop will be held in Little Rock, Arkansas on Tuesday, April 16th. Registration for Little Rock continues to be on record pace, so please sign up today. You're not going to want to miss that. And after Little Rock, we'll be in Deer Valley in June, Des Moines in September, Albuquerque in November. No, actually, we just added Canada, so we'll be in Calgary in the October timeframe. And then, of course, our huge Fiber Connect 2024 conference will be in Nashville, July 28th to 31st. And today at noon Eastern, I have the privilege of hanging out with my buddy Drew Clark on Broadband Breakfast to discuss quantum computing and broadband. So if you're interested in those topics and want to know what the future will bear, please join us at noon today. That brings us to today's Fiber for Breakfast session with Darren Dofher, the CEO, and Mike Maziarka, the Director of Strategy at Baylink Networks. We'll be discussing Nearshore fiber. Before I formally introduce today's guest, I'd like to introduce David Norris from our team, who's going to walk us through some housekeeping items.
Thank you very much, Gary, and good morning to everyone who has joined us today. We appreciate it. Before I go over just a couple of logistics, we'd like to once again thank our platinum sponsor, Fiber for Breakfast, Wesco. Now, if you would please keep in mind, all participants are in listen-only mode today. To ask a question, please type it into the question box located within your control panel on the side of your screen. We will have a Q&A session with our panelists at the end of the session, so please do post your questions. This presentation is being recorded and will be available on FBA's website within 24 to 48 hours, and you'll be able to find that recording in the Events tab under Fiber for Breakfast drop-down option. And at the conclusion of this presentation, you'll be prompted to complete a brief feedback survey. Please take a moment to do so. We appreciate your input. And with that, I will pass things back over to Gary to introduce our panelists again and get us started.
Thanks, David, and good morning. I'm Gary Bolton, the President and CEO of the Fiber Broadband Association. Last week on Fiber for Breakfast, our guest was Shenfei Wang, the Principal Analyst and Head of Wire and Cable at CRU Group, who discussed his latest research findings. Global optical cable demand is poised to grow again in 2024. And the big takeaway from the CRU research is that the demand for fiber is going to continue to grow year over year through the end of the decade. That's given the significant investment of private capital will actually dwarf the BEAD funding. So if you missed it, you can go to the FBA website to watch the replay. In today's Fiber for Breakfast session, we're with Darren Dofher, the CEO, and Mike Maziarka, the Director of Strategy at Baylink Networks, who's going to be discussing Nearshore fiber. Darren is the Chief Executive Officer at Baylink for over 12 years, and he has over 27 years of experience in the telecom industry. Prior to Baylink, Darren was the founder of Terrestrial Networks, a pioneer and global leader in micro-trenching. Mike Maziarka is the Director of Strategy at Baylink, where he leads the company's efforts in owner-operation portion of the business with a focus on commercial component of the network. Mike has extensive knowledge and expertise in undersea fiber optic cable systems, and which are optimized for rugged undersea environments with minimal impact. He also has a strong background in artificial intelligence, data analytics, and customer relationship management. Mike has a bachelor's degree in psychology, which I think you need for this industry, from Vanderbilt, and a master's from St. Thomas University, which sounds like a pretty fun place to be. So with that, welcome Darren and Mike, and for audience, please type in your questions as you go, and we'll work them into the Q&A. So with that, let's get things started. I'll turn it over to Darren and Mike.
Well, thank you very much, Gary and David, both for this opportunity. I think one of the understandings that I've had since I've been recently on board is the ability to share with the industry and the market the difference between what we think of when we hear the word subsea cable and what we're going to talk about today, which is nearshore marine fiber. The methodologies are different. There's proprietary technology and patented technology used to be able to do this. And at the end of the day, what we're going to find, or what I would like to share and make sure gets communicated, is that the cost to deploy is sometimes 1/8 of traditional what we think of as subsea cable, and the service levels are that of terrestrial, and lifetimes and lifespans of those cables are almost infinite because it's not powered. So at a very high level, that's what we're going to talk about today. The presentation I have, I do have a bit of a script in order to keep my a leash and keep me at 15 to 17 minutes. So if you don't mind, I'm going to just be reading from that as we go through the slides. Darren and Gary, please, at any point, should there be a time to interrupt or ask a question real time, please do so. But from what I understand, we're just going to wait till I get through things to be able to have that session. So we go to the first slide, I think, David. So at a high level, governments have concluded that there are direct economic returns and health benefits, as we know, from greater broadband penetration. Both broadband availability and speed are strong drivers in a region's economy. Broadband internet access is not a luxury, but a basic necessity for economic and human development in both developed and developing countries. Governments around the world, as we just heard, have mandates and funds to support getting every home connected with reliable and scalable broadband. Another major driver for new high-speed networks is the explosive growth in data center infrastructure. Data center builders are chasing real estate that is close to where large quantities of power are available. Often there is limited or insufficient network infrastructure in place to support the site. Therefore, new fiber routes are required to get traffic back to existing network exchanges. Fiber optic networks remain the broadband solution of choice, having the greatest scalability and reliability. However, constructing new terrestrial fiber networks in some geographies can represent impossible challenges. Plowing through a nice, wide right-of-way through soft soil on the prairies is great, but most of the world is not like this. Some geographies where new backbones are needed are well built up with roads, homes, and other infrastructure, as we know, that simply make it extremely expensive to get through. There are many remote coastal communities in the world, especially in North America, like Alaska, that will be almost impossible to connect with a terrestrial fiber network. In many cases, there are viable terrestrial routes, but even better marine routes that are overlooked due to lack of understanding. I think we're on to the next slide.
That's the one, Mike. I just changed the title a bit, so you're good.
No worries. There's nothing new about building telecommunications cables in the water. I'm sure everybody knows that the first telegraph cable went in over almost 200 years ago in 1850 between Britain and France. Looking at today's global undersea fiber cable map, there are hundreds of cables in operation, with new projects coming online every year. The cables on the global undersea map are high-profile mega projects, usually crossing oceans, but there are also hundreds of smaller cables that show up on marine charts connecting islands and crossing lakes, rivers, and inlets. The smaller projects use a very similar cable design methodology as the transoceanic cables, but are not powered as there is no need for undersea amplifiers if the distance is short. In general, the current traditional approach to building undersea fiber networks certainly works, but suffers many limitations when it comes to connecting regional locations. Cables are ordered in very long lengths to avoid splicing, as splicing with traditional methodology is difficult and time-consuming. Cable sizes are typically more than 1 inch in diameter with significant weight, and this combination of the two means that the cables need to be transported in specialty cable pans on large dedicated ships in order to get to the job location, making logistics and supply chains extremely difficult. Plus, there are only a handful of cable factories in the world that can make these traditional cables, making lead times very long, I think up to 2 years in some instances. Large vessels are needed for installation, which can cost millions of dollars. And repairing these cables can be very costly, take many weeks, if not months, just procuring specialty vessels and everything that's needed in order to get to the job site. An alternative approach has been developed called Nearshore Networks, which focuses on regional connections in lakes, rivers, and coastal areas. The cable is smaller but equally as robust, and this solves many of the issues associated with larger traditional cables. These cables are typically made in 6-mile or 10-kilometer reels, and 9 of these reels can be shipped in a standard 40-foot shipping container. Splices are not costly and can be done in less than 2 hours. And smaller vessels of opportunity can be outfitted with simple installation equipment to lay and repair cable. This optimized approach has been gaining momentum since 2017, with many projects in the water, most notably the Connected Coast Project, which is a 2,200-mile network connecting 139 communities along the British Columbia coast. Some highlights of the Connected Coast Project. As I mentioned, 2,200 miles fiber backbone spans the entire coast of British Columbia. It connects Canada's largest liquefied natural gas facility. It connects most Coast Guard facilities and along the coast, and connects an array of early earthquake monitoring nodes across the coastline. And we do have a link to learn more about the project should those wish to do so. A couple of case studies, which I think will be helpful. One of the first projects to use this technology was brought online in 2017 is the Coutune Lake project, which is a good project to study to help understand what the technology can do. Coutune Lake is a very large lake with several communities along its shoreline, and the entire area is quite remote and suffered from very poor internet speeds. The mountainous terrain all around the lake made it very expensive to construct overland fiber routes and would result in a network that would be highly vulnerable to slides and wildfires. A broadband gateway was available at one of the larger communities on the lake, so a 23-mile nearshore network was designed to extend a marine cable from the gateway up to and connect the 4 other communities. The project is a great success. Overall budget came in at 1/8 of the cost of building overland, and the network enjoys great reliability at very low maintenance costs. Just some highlights. The project length is almost 30 miles, 23 miles. We have 5 landing sites. There are 8 marine splices in the water, of course. The maximum depth of the lake is roughly 450 feet. And we stood that up and turned that on in 2017. And knock on wood, we have yet to have a service disruption or a locate request. Another interesting example is the Trout Lake Fiber to the Home project, where 60 homes are distributed on 5 small islands in a lake and are connected to broadband service via the water as opposed to the land. A cable is stitched in and out of landings that are located between 2 properties, and each home gets a fiber connection which routes back to a service point on the main shore of the lake. And then you can see that right there. David, you just brought that up.
Yep.
Nearshore network technology can be used also to build dedicated networks to connect data center properties. Plans are underway to build an extensive 675-mile network in Lake Ontario and Lake Erie, which will serve more than 15 prime data center properties. Larger populated islands such as Puerto Rico could build a 320-mile nearshore network around the entire island with 32 landing sites, and this network would provide a self-healing ring that would be more reliable than the current terrestrial networks that are vulnerable to tropical storms. Nearshore networks share similar vulnerabilities as traditional undersea networks, with commercial fishing being the main culprit. Often nearshore networks are routed through areas that are not exposed to commercial fishing and would have reduced risk. Terrestrial networks have plenty of risks as well, with forest fires, storms, slides, construction, vandalism, and with repair costs significantly less than traditional undersea systems and taking less time, nearshore networks may have an advantage. Nearshore networks, in regards to repairs and maintenance, nearshore networks are built with a cable system that can be recovered and repaired with a smaller vessel of opportunity. Repair times can be as low as a few days, with costs ranging from $40,000 to $150,000 US. This is a fraction of the cost of subsea maintenance and fixing. With the inline splice case system that we use, a cable joint can be accomplished in less than 2 hours on the boat. A repair is accomplished by grappling for the cable in the damaged area, lifting it to the surface. That damaged section is then cut out and a new section of cable spliced in to replace the damaged section. This is referred to as a two-point repair. Repair times are comparable to the repair times of terrestrial networks, and similar service levels are offered as well with these networks. I think key takeaways are repair costs are a fraction of what we would think of in a subsea cable use case, 40 to 150,000 US. Small vessels of opportunity are used as opposed to the large ships that are required for subsea cable repair. Cable splice can be done in less than 2 hours on a boat, and service levels are similar to that of terrestrial networks. I believe, yep. Baylinks has been operational and in business since 2011. We are a turnkey telecom infrastructure provider with a focus on providing high quality economic undersea networks. We build, own, and operate fiber optic networks. And uniquely design our networks to be near shore. Our focus is on near shore. Our technology and proprietary methodology are focused on near shore use cases and applications. Our innovative and patented cable technology is disruptive to the industry. I think some key takeaways, key features of the system. It's proven proprietary undersea cable technology, which is disruptive in the cable C market, which has been pretty staid in terms of the way that they do things for the last 25 years. Low maintenance costs. Repairs can be performed with small local vessels of opportunity. Economic and designed to feasibly link very small remote communities. Excellent supply chain. Large projects exceeding 1,000 kilometers can be supplied in 4 months, which is unheard of in any other application with the traditional cable manufacturers. It ships in standard shipping containers, which is not the case with the others. And we have the rapid and robust splicing system. Use cases and applications are regional and long-haul fiber backbones, data center connectivity, offshore platform connectivity, science and undersea monitoring, and any fiber connectivity that can be routed through a waterway, lake, river, estuary, ocean shore, The proprietary and patented technology component. At the core of the system is a small form factor 20 kilonewton cable. The cable is produced in 10-kilometer lengths and weighs approximately 2,800 kilograms each. This can be transported in standard shipping containers and handled and distributed as needed throughout the standard transportation logistics system. Having simple standard logistics helps to enable economic and successful projects. Each cable reel is pre-terminated with pigtails on the inside tail to facilitate easy testing during installation. The next major element of the system is the inline splice case, which can be completed and fully functional in less than 2 hours. The case has triple O-ring seals on the cable entry and on the housing, and is flooded with hydraulic fluid after completion of the splice. The strength members are clamped onto a stainless steel tray, which retains the tensile strength of the cable system, and the rubber end cones provide strain relief for the cables as they enter the case. There are no external metal parts on the case. Additional armoring systems are used to protect the cable in harsh environments. At shore landings, ductile iron split pipe is used to create secure landings that can tolerate constant wave crashing and exposure. For high current rocky areas at sea, a rigid PVC outer jacket is added to the cable for greater protection. Key takeaways here are the small form factor, 20 kilonewtons, which Darren can speak to when I finish as to just what a kilonewton is. Inline splice case takes 2 hours to do a repair typically, and additional armoring systems for harsh conditions are available and used frequently. Where can we deploy nearshore networks? Everything up to and including entire coastlines can be connected. Nearshore networks simply implies that the system was designed around using marine corridors to enable regional fiber backbones. There is often a need to land the cable at many locations along a shoreline. Therefore, the route tends to stay close to shore to reduce route length. The small form factor cable allows for deployment with smaller vessels and equipment and can operate in most settings. So I think the takeaways as to where this is applicable and where we feel we are a truly differentiating solution are in swamps and estuaries, canals, slow-moving rivers, lakes, coastal areas, which include ocean shores. And I think that kind of buttons up our high-level overview of nearshore networks.
Well, Mike and Darren, this is super interesting. And just to make sure I understand, so you can be able to drop this, how big, like if, you think about every communities are typically built around some kind of waterway, right? I mean, they're built on rivers and on lakes and along the shore, if you look at most coastal areas. So you can drop this anywhere there's water. Like how big does the river have to be or creek to be able to safely drop a fiber cable in?
Gary, we can put this cable just about anywhere. If there's a swampy little channel running in a direction that you can get approval to put it in, it would do really well in there.
So like I'm thinking tribal areas, you think about tribal broadband, so critical, and the big issue for tribal is middle mile. How do you it's one thing if a tribe was just right near, a high populated area and you could just drop some fiber over it, but usually it's not. And so you could just be able to find a river or creek that goes to a tribal area and be able to provide fiber.
I think our limitation is high current. Like if you have a babbling brook, that's not going to be a go. But if you have a pretty slow moving channel somewhere, maybe it's even an irrigation channel, that's a possibility. So, anything other than really fast current is doable, I would say.
There's a ton of questions. Let me get into these. So on land, you have things like service loops. How do you set a slack loop in the path, or is there one?
No slack loops needed. Inherently, you deploy the cable with a certain percentage of slack, usually around 1%. It kind of depends on the bottom conditions. So it won't be tight on the bottom. That would be a no-no. So you can generally pull the cable to the surface because of that little bit of slack in the system, and then you can access the cable. And I mean, sometimes you have to cut it to bring it to the surface, but yeah, you'll have a tail, and then you can do your splice. So you don't really need that standard 15-20 meters of slack to do a splice. You kind of get that when you pull it out of the water.
What does the operator do? I mean, I suspect that operators, operators, my little conference room, the lights go out when I don't stand up, that they're not typically going to have a boat. They have their Grady White ready to go pull up a cable and do some maintenance. So they just call you guys, and you guys run in and pull up a cable for them?
Yeah, definitely it's specialized expertise to get this stuff done. Not that it's difficult, but you wouldn't want to head out if you've never dealt with it before. So anything we put in the water, we make sure there's a maintenance plan for it. We'll either have our own boats in a standby mode, or we'll know of a good set of boats up the coast that are there for us when we need them. And we'll make sure, there's a few specialty tools we use, so we'll make sure those are in place. And yeah, if something goes wrong, they would call us up, and we'd hop on it and get it fixed.
Let me try to get through as many of these questions as I can before we run out of time. But another question came in: is this a viable solution for lakes that freeze over?
Yes, absolutely. There's even a trick. You can actually trench through a frozen lake and install this, which actually and still get pretty good productivity.
That's interesting. Also, are the delivery drums, can they also be used for installation?
Yep, that's exactly what we do. We don't respool onto another system. We literally take the drums from the factory, put them on our specialized reel stand, and install straight off that.
Zip them right on. What about approvals? I mean, environmental. So when you're talking about wetlands restrictions and stuff like that, is that complicated?
It's not complicated, and it's not impactful at all. So we always get these permits. It just takes, you have to do your homework. You have to have an environmental management plan, which is kind of standard for anything you do these days. But we always get the approval. I mean, there's the odd time where there's something super sensitive in an area, but usually we can easily work around that.
You guys do this every day. You have it figured out.
Yeah.
Hey, what about, have you done work in Virginia, specific along the Eastern Shore and Chesapeake Bay?
Not yet, but we've been looking at it pretty closely these days. I think we're definitely going to come up with a project there, a Nearshore network. I think there's a real demand. So many data centers. Yeah, definitely we're looking at it.
All right, what is your rough cost per foot or mile? I don't know how you measure a kilometer.
We see turnkey projects go in the water for between, say, $28 a meter and say $50 a meter. So just
$20 a meter.
Divide that by 3.28 to get.
What is the typical range of number of strands you have in a typical cable?
We can go up to a 72 count cable in this, and we do lots of 24 for for projects.
And we can lay multiple cables too.
Okay.
Yeah.
What about waterways that don't hold water year round? Is that a no-go?
It's still workable. Yep. I mean, what you might do in those waterways, you might install the cable when it's flooded, and then come back when it's dry and do a little bit of burial if you think it's at risk. But yeah, it's certainly doable.
All right, some shout outs from your friends at Infinera. They love you guys. All right, well, listen, this is a lot of great questions. I think this is fascinating. I think this is a really opportunity to be able to get fiber quickly to some places that are difficult to reach in a costly manner. So thank you guys for everything you do, and I really appreciate you sharing this information with our audience. And I look forward to getting together again next Wednesday for Fiber to Breakfast. So please join me, and hopefully I'll be back on the mainland next week. And so thanks everyone.
Thank you.
Thanks, Mike. Really appreciate it.
Thanks a lot, Gary.